Hi everybody, so we are going to teach about how atoms bond today. My name is Courtney and I'll be going over the atoms and elements.
Hi, I'm Andrea and I'll be going over chemical bonds and the 3 different bonds.
Hi, I'm Candace and I'll be going over molecular attractions.
And my name is April and I'll be going over how atoms bond with electrons and the shells.
Alright, let's begin. Alright, what is an atom? So hydrogen is one of the lightest atoms and makes up more than 90% of the atoms in the known universe. Most atoms are formed during the beginning of the universe about 13.7 billion years ago. Atoms are produced in the stars and pulled together by gravitational forces. You are made of stardust. Alright, so this is what an atom looks like, and atoms are ancient and small. They are submicroscopic. A single grain of sand contains about 125 million trillion atoms. This is a conceptual model of an atom. Protons will carry a positive charge and are about 1,800 times as massive as an electron, which carries a negative charge. The neutrons are in the nucleus and are neutral. Neutrons accompany protons in the nucleus. As you can see here, the protons are purple, the neutrons are green, and they're about the same mass as protons but no charge, electrically neutral. So this is called the periodic table of elements, and it's going to be only containing the pure substances of any kind of atom. They cannot be separated into simpler materials by chemical or physical means, and there's over 100 existing elements are listed and classified on this periodic table. So how do you read the periodic table? This is carbon right here, and the number 6 is going to be the atomic number, which is the number of protons in the element. The atomic mass right here is 12, and if you don't have to memorize the periodic table, because you can learn to read it. The elements are highly organized. Each vertical column is called a group, and each horizontal row is called a period. And these are some examples of some elements. You have gold right here in the pure form and mercury, which you can find in old thermometers.
Alrighty, and now let's review.
Atoms make up everything that we see on Earth. And they are the smallest components of matter. The diagram of an atom is shown here. The center of the atom is called the nucleus, which is made up of particles called protons and neutrons. Protons being red and neutrons being yellow. Protons have a positive charge, and neutrons have no charge. The nucleus contains almost all of the mass of the atom, and therefore most of the atom's weight is located in its center. Surrounding the nucleus are electron orbitals. The diagram here is used as a way to represent the electron orbitals, with a certain number of electrons sitting on each orbital. The electrons have a negative charge and have an extremely light mass compared to the rest of the atom. So what is an element? Well, an element is made up from atoms. For example, copper is an element that is made up of copper atoms. Now on the left is a representative of a copper atom, and many atoms just like this combine together to form the copper element, which is located on the right. And this is how we would find copper in nature. So in summary, atoms are just really, really small particles made up of protons, neutrons, and electrons. And like atoms come together to make up elements. And elements are just a form of something as we would find it in nature. And as we'll find out later, it actually comes down to the amount of protons, neutrons, and electrons that determine what kind of element the atom will form. Atoms make up everything that we see.
1 second here.
And they are small.
Let's move on. Alrighty, so I will be talking to you guys about the inside of an atom. So this is a conceptual model of the atom. Because atoms are so small, we can never have a physical model. So it organizes the number of electrons in an atom, and as you can see, there are 7 centric cells. And the first orbital allows for 2 electrons in there, and then it maxes out. And then the third and fourth orbital maxes out at 8, and the 5th and 6th is at 18, and the 6th and the 7th is at 32. But each level past 8, they normally max out at 8 as well, but still other electrons will fit. So what do these shells have to do with atoms bonding together? Each atom has its own configuration of electrons, and atoms bond together through their electrons. What we're going to be focusing on with bonding is the valence electrons, and the definition for that is electrons in the outermost shell of an atom. These are the ones that can participate in chemical bonding. So I'm going to give you guys some examples. These are examples of elements on their valence electrons. So here we have magnesium. In the first shell, you can see that there's 2 electrons. And then in the second shell, there's 8. There's 1, 2, 3, 4, 5, 6, 7, 8. And then in the third shell, it only has 2. So those are the 2 valence electrons because you need 8 to fulfill it. In oxygen, we have 6 on the outermost shell. In sodium, we have only 1. And in chlorine, we actually have 7. So let's look at magnesium and oxygen. Magnesium has 2 valence electrons, and oxygen has 6 valence electrons. So if they bond together, they would help each other fulfill the outermost shell because 6 plus 2 equals 8. And in this diagram, you can see these are the 2 valence electrons. This is the electron dot structure. And then you add it with the valence electrons of oxygen. And as you can see, they're sharing to help each other out. So magnesium gives oxygen its 2 electrons, while oxygen helps give the 6 to help to balance each other out. And then another last example is sodium has 1 valence electron, as you can see right here, and chlorine has 7 electrons on the outermost. So when they bond, they would fulfill each other's outer shells, totaling to 8 electrons, and that's how we get sodium chloride.
So now I'll be talking about chemical bonds. So chemical bond is an attraction between atoms. This attraction may be seen as a result of different behaviors of the outermost valence electrons of atoms. So what happens is that the behavior merge into each other and in various circuits of them, so that there is no clear lines in between them. There's also 3 types of atoms, and that are ionic, covalent, and metallic. And here's a video of chemical bonds.
A chemical bond is an attraction between 2 or more atoms that holds the constituent parts of each atom together. Or, to use the language of chemistry, that enables each atom to gain stability. A chemical bond is not a physical structure, but an energy relationship. There are different types of chemical bonds, but all involve electrons, which are either shared or transferred between the bonded atoms. For an atom to be stable, its outer shell of electrons, its valence shell, must be full. For most elements, the valence shell can hold 8 electrons. Due to their small size, atoms of hydrogen and helium can only hold 2 electrons. Among single atoms, the valence shell is full only in inert or noble gases like helium, krypton, neon, and others along the right side of the periodic table. Noble gases have a very stable electron configuration and, as a result, do not seek to bond with another element. But for all other atoms to be stable, they must gain or lose electrons, or share them with other atoms. For example, magnesium has 2 valence electrons and is therefore unstable. To gain stability, magnesium will lose 2 electrons, leaving the new valence shell full. This will result in magnesium forming an ion with a +2 charge. On the other hand, chloride atoms have 7 valence electrons and will tend to gain a single electron to fill their valence shell, resulting in an ion with a -1 charge. Positively charged ions are attracted to negatively charged ions to gain neutrality. In the previous example,
one magnesium ion will pair with two chloride ions to produce a molecule of the neutral salt magnesium chloride. Instead of gaining or losing electrons, some atoms share electrons to gain stability. When this occurs, a different type of bond, known as a covalent bond, is formed between the atoms. If these electrons are shared equally, meaning the electrons spend the same amount of time in each atom's outer valence shell, the result is a nonpolar covalent bond. If the electrons are shared unequally, meaning the electrons spend unequal time in each atom's outer valence shell, the result is a polar covalent bond. A good example of a polar covalent bond is the hydrogen-oxygen bond in a water molecule. As a result of unequal sharing, atoms of a polar covalent bond will have a partial charge. It's common for hydrogen atoms of a polar covalent bond to be partially positively charged. Because unlike charges attract, these hydrogen atoms will form hydrogen bonds with other atoms that have a partial negative charge, such as the oxygen portion of a water molecule. While a single hydrogen bond is weak, collectively they can be quite strong. For example, forming the surface tension of water.
Perfect timing. You guys have to. There you go.
A chemical
Okay, so like the video showed us, I'm going to be breaking down the chemical bonds, the 3 chemical bonds. So the next one is ionic bond, and they're, like the video says, electrons are transferred between valence shells and atoms. They're always formed between metals and non-metals. The atoms that accept the electrons become negative charged. So an example are sodium and chloride, and then the sodium and hydroxide. Okay, covalent bond. So covalent bond form when a bond atoms have a lower total energy than the widely separated atoms. And these are nonmetals bond with nonmetals. By sharing them, their outermost electrons, atoms can fill up their outer electron shells and gain stabilities. You can see in the video that we also have the polar covalent bond and the non-polar covalent bond. And the polar one is created when their shared electrons between atoms are not equally shared. And then this would be the opposite. It would create when the atoms share their electrons equally. Okay, and the last one is metallic bond. Metallic bond is a sharing of electron between many atoms of metals elements. It's given metals their unique properties that we don't see in non-metal substance, and valence electrons are shaped in electron C.
And then what are molecular attractions? There are 4 molecular attractions: an ion dipole, a dipole-dipole, dipole-induced dipole, and an induced dipole-induced dipole. And molecular attractions vary in strength but are weaker than chemical bonds. They are also responsible for determining whether a molecule compound is a gas, liquid, or a solid. An ion dipole is the attraction between an ion and a dipole. And it is commonly found in solutions and is especially important for solutions of ionic compounds and polar liquids. An anion is a negative ion, and it attracts the partially positive end of a neutral polar molecule. And a cation is a positive ion, and that attracts the partially negative end of a neutral polar molecule. And an example for an ion dipole is sodium chloride in water. A dipole-dipole is the attraction between 2 dipoles. A dipole-dipole is much weaker than ionic or covalent bonds, and they also have a significant effect only when the molecules are either touching or close to touching. And they occur when partial charge forms within a molecule because of uneven distribution of electrons. And an example of a dipole-dipole is cohesive forces within water. dipole-induced dipole. A dipole-induced dipole is an attraction between a dipole and an induced dipole. This attraction is a weak attraction that results when a polar molecule induces a dipole in an atom or in a nonpolar molecule by messing up the arrangement of electrons in the nonpolar species. And an induced dipole occurs when an ion or a dipole induces a molecule or an atom that does not have a dipole. An induced dipole happens between nonpolar molecules. Nonpolar molecules and noble gases act as a temporary induced dipole, and these molecules that have induced dipoles may also induce neighboring molecules to have dipole moments so that a large network of induced dipole interactions may exist. And an example of an induced dipole is when soap attracts grime by induced dipole. And then this is a demonstration of how atoms bond.
Alrighty, so I hope here's a little overview of just what we went over in conclusion. You know, what makes up an atom, what is composed of, how you can look at the periodic table yourself and find what elements you want to see how they bond and what group they're in on the periodic table, with if they're metals, non-metals, gases. And we went over the valence electrons, how atoms even get to bond. So like examples we did is sodium only had one valence electron in the outer shell, and it mixed with chlorine because chlorine had seven valence electrons, and so because 7 + 1 = 8, they were able to bond and fulfill each other. And like we went into the different types of bonds, right? Can you go over?
Yeah. So we went over we went over chemical bonds, and then how the importance of the 3 chemical bonds. So that's ionic, covalent, and metallic bonds, and then we got to see how each one does different emerge in the atom. So for ionic, we see the metal bonds with metals. Metallics, metal bonds metals, and then ionics were non-metals bond non-metals.
And then we also got to see molecular attractions, and there are 4 of those attractions, and that is an ion dipole, a dipole-dipole, an induced dipole, and an induced dipole-induced dipole.
Yep, and then at the very end there you saw a little video demonstration that we put together with Legos to show just exactly how many different ways atoms can bond together, and we really appreciate all the time that you took to watch our lesson today, and hope you learned a lot and hope you bond with atoms and elements yourself.
Mm-hmm. So thank you, Dr. Abros and CSUSM, for the support and motivation to teach science, and thank you for you guys for listening and learning with us. It's a process, and hopefully you begin to see the elements all around you.